pitched in is.
Okay, so integration technique number 3, partial fractions. So how do we integrate a rational function if we can't guess and check? For example, determine the integral of x plus 5 over x squared plus x minus 2 dx. Difficult to guess and check. So in this case, we will express the function as a sum of two simpler rational functions. Notice the denominator factors into two binomials. Okay, so what's x squared plus x minus 2 factor 2 into?
X minus 1, x plus 2.
Yeah, so.
Or x plus 2, actually, not.
Okay, so x plus 2 and x minus 1. And
What I said.
what we can do is this, right? So we can write x plus 5 over x plus 2 x minus 1 is equal to a over x plus 2 plus b over x minus 1. Right? And just think back to when you were adding rational expressions, you would have started with there's something over x plus 2 plus something over x minus 1. The common denominator was x plus 2 times x minus 1, which means you had to multiply the a times x minus 1 and the b times x plus 2. Okay, so the idea is if we start with this, we end up with this, and that's going to be your numerator, right? That the a plus b has to be x plus 5. So we have this. Now this can be done by equating coefficients and using a system. So you could expand this, right? You go ax minus a plus bx plus 2b is equal to x plus 5. Right? And then you could group the ax and the bx and say that means that a plus b. But there's an easier way to do this, I think. And that is we can say, well, let's start off by saying let x equal 1. If x is 1, what happens to this? It goes away, right? X is 1, this is gone. We end up with 3b is equal to 6. We get b equals 2. So I think that's an easier way to solve this than to expand it out and worry about a system, right? We'll just say, all right, so let x equal 1. So it gives us a times 1 minus 1 plus b times 1 plus 2 is equal to 1 plus 5. Now, I wouldn't bother writing this out. I mean, you chose x to be 1 because you just said, okay, that gets rid of the a term. And so you've got 3b is equal to 6 and b is equal to 2. So similarly, what could we let x equal? Negative 2. So if we want to solve for a, we'll let x equal negative 2. So a times negative 2 minus 1 is equal to negative 2 plus 5. So negative 3a is equal to 3, and a is negative 1. Okay, so if we went back to here, if we had started with, I'm just thinking 20, if you had negative 1 over x plus 2 plus, what did we say b was? 3, 2? Plus 2 over x minus 1, and you worked this, you would end up with x plus 5 over x squared plus x minus 2. So we've successfully split this up into two terms, which are easy to do the integral of, right? So we've got negative 1 over x plus 2 plus 2 over x minus 1. The sum of an integral, the integral of a sum is the sum of the individual integrals. So this is negative 1 over x plus 2 dx plus 2 over x minus 1 dx.
3 over x minus 1?
No, b is 2. That's okay.
I'm so ashamed of myself.
I was partially confused too. Okay, so what's the integral of negative 1 over x plus 2? So it's just the negative of the ln of x plus 2, right? Got an x plus 2 on the bottom, and this thing's negative, so it's negative ln absolute value x plus 2 plus, what's the integral of this? Yeah, 2 ln whatever plus a c. And we can reorder this so we put the positive term first, if you like. So 2 ln absolute value of x minus 1 minus the ln the absolute value of x plus 2 plus c. So that's how we're going to do things like this technique of partial fractions where you can't just easily sort of guess what it's going to be. And there are a number of cases. All right, so what is it? The example above involves a rational function that can be expressed as a sum of 2 or more rational functions with denominators that are non-repeating linear binomials. Okay, so non-repeating, there's an x plus 2, there's an x minus 1, that's it, right? There's nobody is being squared. In general, when using the technique of partial fractions for integration of rational functions, we will always express the rational function as a sum of simpler rational functions, right? And whose integrals then are pretty easy to figure out, right? You just got a number over an expression. So there are various types. Type 1. The degree of the denominator is greater than the degree of the numerator, and the denominator factors into 2 or more non-repeating linear binomials. In other words, pretty much just the one that we did, right? It's just like the one that we did. So start off, what we're going to do is start off, just take the 3x minus 20 over x squared minus 5x, take it out of the integral, we're just going to take it, simplify it, and write it as a sum of partial fractions, okay? So we start off by just taking the 3x minus 20 over x squared minus 5x, and we're going to work with that, and we want to write it and get it to the point where we have it as a sum of partial fractions. Okay, so we got to factor the denominator, okay, into 2 or more non-repeating linear binomials. So in this case, we just have 2 linear. Well, one's a monomial, one's a binomial. And we want to write that, so we want 3x minus 20 over x times x minus 5 is equal to a over x plus b over x minus 5. All right, so we're splitting out that denominator into these two, right? So writing it as a sum.
Isn't it subtract?
Isn't it subtract? Nope, it's plus. But then maybe b is negative, right? So we always just write it as a plus, and we figure out what are a and b, and if one of them is negative or both or whatever. They could both be negative, both positive. Okay, so what do we say? Well, then if I'm going to do this, right, it's going to be a times x minus 5 plus b times x. And that's going to be equal to the numerator, right? Because the denominator, that's going to be x times x minus 5. So a times this plus b times that is equal to 3x minus 20. Now we could expand it, right? ax minus 5a plus bx, and then say the ax plus bx is going to be 3, and solve a system, right? Or we can let x equal 0, which means what? Let's go a little bit simpler, right? So if x is 0, we got negative 5a is equal to negative 20. So what's a? So a is equal to 4. And then, what are we going to let x equal? 5, right? So what we do is we say we'll get rid of the b, right? We'll just figure out what's a. Well, so a has to be 4. What's b? Well, let x equal 5. Takes this out, we get bx equals 3 times, I mean, we're not getting rid of that 3, so let's write that out. So it's 15. So we've got, oh, wait, sorry, let b equal 5. Let x equal 5 gives us 5b is equal to 3 times 5 minus 20. Okay, so 5b is equal to negative 5, and b is negative 1. So there's your negative for the b, right? So we'll be minus. All right, so we've done that. So now we go back over here, and we say the integral of 3x minus 20 over x squared minus 5x dx is equal to, okay, we've got our a and b. So a is 4, so it's 4 over x. And we've got b is -1, right? So instead of writing plus, we'll go minus the integral. Okay, now we can go with b is 1, so we've taken care of the minus. 1 over x minus 5 dx. Okay, and those integrals are easy to do. What's the first one? 4 ln x, so it's 4 ln absolute value of x minus.
The absolute value of x minus 5.
Yep.
Plus c.
Plus c.
Yeah.
Okay, so.
Oh,
interesting. Got your name on it. Zoink.
You had mine on.
Moving forward. Type 2. The degree of the denominator is still greater than the degree of the numerator, and the denominator factors into 2 or more repeating linear binomials. Okay, so what's that mean? Well, let's take the denominator and factor it. So we got x cubed minus 2x squared plus x. So first step is to do what? Take out an x, right? So we got x, and then x squared minus 2 plus 1, and minus 2x plus 1. How does x squared minus 2x plus 1 factor? X minus 1. Quantity squared, right? It's just the square of x minus 1. So, what does that mean? It means that our denominator could have an x in the bottom. So, let's do this. For illustration only, you don't need to write that out, right? But so the denominator could be the denominator could have an x minus 1, or an x minus 1 squared. Right? Or it could be an x minus 1, could be an x minus 1 quantity squared. So we have to deal with that. So we're going to split this out, and we're going to say, okay, 2x squared plus 3 over x cubed minus 2x squared plus x. Okay, so forget about the integral for now. We're just working on getting the partial fraction for this. We can say it's a over x plus b over x minus 1 plus c over x minus 1 quantity squared. Now, it could be that one of a, b, or c is 0, right? We don't know, but we have to take into account all the possibilities. So when we have a repeating linear binomial, then we take it as, well, there could be an x minus 1 factor, right? That's part of this, and there could be an x minus 1 quantity squared. So we got to deal with a, b, and c. So we go to expand this. We're going to say, well, what does the a have to be multiplied by? Just x minus 1 squared, right? It's already got this. So our denominator consists of an x and an x minus 1 squared. Right? That's our denominator. So the a, it's got to be multiplied by, it's just got the x here, it's got to be multiplied by x times x, or sorry, x minus 1 squared. What does b have to be multiplied by?
X and x minus 1.
An x and an x minus 1, right? And what does c have to be multiplied by? Just x. And what's that going to be equal to? Well, that's the numerator, right? 2x squared plus 3. Okay, so what are we going to do? Yeah, so if we set x equal to 0, what's gone? B and c, right? So we let x equal 0. So on the left side, we got 2x squared plus 3, which is 3. And on the right side, we've got a times negative 1 squared. So then we know that a has to be equal to 3, right? So if you let x be 0, cx, c times 0, there's no c. If you let x be 0, b times 0 times negative 1, also 0. So all we've got left is 1a is equal to, in this case, 3. So we've got a is equal to 3. Okay, what else?
X equals 1, and then you only have CX.
Yeah, so let x equal 1. So if x is 1, what's the left side here?
5.
5. So we got 5 is equal to, okay, a is gone, b is gone. Okay, so now we know c is 5. So how do we get b? No. You can only use a 0 or a 1, right?
You can plug in any x value you want because you know what a and c are, right?
It's true. We could do that. And another way we can look at this is, if I expand this, but let's look at it a little more systematically perhaps. If I expand this, I'm going to get a x squared minus 2x plus 1. And if I expand this, I'm going to get bx squared minus. So the x squared is going to come from what? It's going to come from, we're going to end up with an ax squared plus bx squared. Right? So here, a times x squared, but where does the x squared term come from? Ax squared plus bx squared, and what's that got to be equal to? That's got to be equal to 2x squared, right? Because that's where our x squared term comes from, isn't it? But we know a, right? So we've got 3x squared plus bx squared is equal to 2x squared, so what's b? No, let's just subtract. Don't divide.
Oh no.
3 plus what is equal to 2?
Oh no. Negative 1.
Negative 1, right? So the b is equal to negative 1.
I'm sorry.
Okay.
That totally makes up for my
So,
sorry.
if we can get rid of a term, which we let's throw brackets around that. It's like if we can get rid of 2 of the terms, and we can do that by letting x equal 0, then we get a. If we can get rid of 2 of the terms, and we can do that by letting x equal 1, so that gives us c. And then, like you said, we could really put any value in, but if we say, all right, look, what else do I know? Well, I know that this is really a times x squared minus 2x plus 1, and this is b times x squared minus x, and that's a c. I could expand that, but it's like, wait a sec, this is going to be ax squared plus bx squared. That's got to give me the 2x squared, right? And I already know a, so bang, b. Okay, so now we have a, b, and c. So we can write this out. So what have we got? The integral of 2x squared plus 3 over x squared minus, x cubed minus 2x squared plus x is equal to, well, it's going to be the sum of these 3 integrals, right? So it's going to be a, so 3 over x, so it's the integral of 3 over x dx. B is minus, so minus the integral of 1 over x minus 1 dx. And c is positive, so plus the integral of 5 over x minus 1 squared dx. Okay, so the first 2 are easy to do. So what's this one?
3 ln x.
So 3 ln, and when you say x, I know you mean the absolute value of x, so I'll just write that. So 3 ln x. Next.
Minus the ln of the absolute value of x minus 1. Someone actually know that shit. Bruh.
Plus, okay, can we do this one?
Yes.
Just write 10 ln.
No.
Do you take 2 off the x minus?
No, but it's not good. It's negative 1. Where are you taking the 2? So it'll be minus.
It's just, yeah,
It's minus 5
you're-
over x minus
yeah, you're
1.
just
I didn't
doing,
mean to sound like that.
it's minus 5 over x minus 1.
I said it first.
I already had it done 5 minutes ago.
God damn it.
Okay.
You gotta take this from me.
Now, if you have problems with it, you could do this with the U-substitution. right? You can let u equal x minus 1. So here, I'll just sketch that out quickly. So, I mean, we're done. This is it. Okay, it's over. It's finished. If you're looking at that one and you're not seeing it, remember, some are easy to get and some aren't. Some you see and some you don't. And if you don't see that, then you can just say, let u equal x minus 1. Right? The idea is we want to get a single thing down here, right, in the denominator from the U-Substitution. So you let u equal x minus 1. So du is going to be 1 dx, so just dx. And so we've got 5 times, so the 5 is a constant, just come out, and you've got 1 over u squared du, okay, which is 5 times the integral, and if you like, go negative u to the negative 2. Right, what do? We got to increase the power and then divide. So it's going to be negative 5 u to the negative 1. Sorry, no integral there. We're doing it now. 5 u to the negative 1 plus the c. So 5 over u, and that's 5 over x minus 1. Okay. Negative 5 over x minus 1. So we got a negative and 5 over x minus 1. So type 3, the degree of the denominator is greater than the degree of the numerator, and the denominator has an unfactorable quadratic factor.
Oh boy. Oh boy.
Okay, so let's take a look at this, see what we're going to do. So what's first thing? Well, we can take a 3 out of the top, right? Go x squared plus 5. And out of the bottom, we've got a 2x. And what do we got? X squared plus 3. And that's unfactorable, right? We got the x squared plus 3. Okay. So if we like, we can pull the 3 over 2 out, right? Like that can just go in front. And then we can worry about this, right? We'll worry about the x squared plus 5 over x times x squared plus 3. Okay, so this is what we want to worry about. Okay, and the 2/3 we'll just pull out when we actually go to do this. So don't write this down, okay? Stop writing. If we try and do this, right? So if we're going to say x squared plus 5 over x times x squared plus 3 is equal to a over, let's say, x squared plus 3 plus b over x. Don't write this down. This is not correct. Right? I mean, we're going to see that you can't do this. So we'd have like ax is, oops. So we multiply, right? Get ax plus b times x squared plus 3, and that's going to be equal to the x squared plus 5. So you can see I got bx squared, right? So that means this is the only x squared in here, so b has to equal 1. If b is 1, well then a has to be 0, right? Because there's no x term in here. So we get x squared plus 3 is equal to, you can't do that, right? X squared plus 3 equals x squared plus 5, right? There's no other values you can put in. So we got to do something a little bit different. So here's the different stuff we have to do. Now you can write this in. So up here, we're going to write ax plus b over x squared plus 3 plus c over x. Okay? So we have to introduce this linear ax plus b up here over the x squared plus 3, right? The unfactorable quadratic factor. Okay, so expanding, we end up with x squared plus 5 is going to equal ax plus b times x, right? So you're going to multiply these, plus c times x squared plus 3. Okay, and now we want to find our a, b, and c. So in this case, it's kind of handy to multiply this out. So we get ax squared plus bx plus cx squared plus 3c. Okay, so that's all that. So what can we tell from that?
B is 0.
So b has to be 0, right? Because there's no x term, and the only x term over here is with b, so we know that b is equal to 0. Therefore, b equals 0. Okay, what else? Yeah. Well, let's start with, if you let x be 0, you're just going to get 3c is equal to 5, right? So we get c. So let x equal 0. You're not wrong, and we could do it in either order, right? It doesn't matter. I'm just choosing, all right, if we let x equal 0, we get 5 is equal to 3c, so c is 5/3. And then, what do? Well, we put the x squared together. Actually, maybe you do have to do it in this order, because you need to know c before you can.
Yeah.
Yeah. Okay, so now let's worry about the x squared, right? So x squared is equal to ax squared plus cx squared, right? That's where the x squared comes from. Ax squared plus cx squared. And we know c. So x squared is equal to ax squared plus 5/3 x squared. So what's a? Negative 2/3, right? So then a is equal to negative 2/3. Okay, now we're ready to go. So we go back up here and we say the integral, actually let's do this, 3/2 times the integral of x squared plus 5 over x times x squared plus 3 dx. So we've taken, we discovered this 3/2 when we did our initial factorization, and just, why not get rid of that, right? Just move it out. So it's going to be 3/2 times, okay, so what do we got? We got c is 5/3, right? So let's just write this as 5/3 times the integral of 1 over x. Okay, so we've got c is 5/3. So this guy here is 5 over 3x. But 5 over 3 is a constant. So let's go 5/3 times the integral of 1 over x dx. So that takes care of this guy. The b is 0, so we've got ax, and a is negative 2/3. So we can pull that. So go minus 2/3 times the integral of, okay, so that takes care of the a, that's gone. The b was 0. We just get x over x squared plus 3. X over x squared plus 3 dx. Okay, and 3/2 is multiplying that whole thing, right? Okay, let's go down here where we've got some room. So 3/2, got the 5/3. What's the integral of 1 over x dx? Just ln x, right? And when we say ln x, that's what we write, right? Ln of the absolute value of x. Got minus 2/3, okay, so we've done this. Minus 2/3, and I need the integral of x over x squared plus 3.
Ln of the absolute value of x squared plus 3 over 2.
So we got the ln of the absolute value of x squared plus 3, okay? Then this inner function is going to give us a 2x, right? And we need to get rid of the 2, so then we'll just divide by 2. And we'll throw a c outside there, right? Plus c. Okay, so this 2 takes care of this 2. And what do we got? So 3/2, or sorry, yeah, 3/2 times 5/3 is going to be 5/2. Well, wait a sec, what are we going to have? Oh, you know what? Maybe. All right, let's do this. So we got 5/2. These guys are gone. Ln absolute value of x. The 3 is going to be gone, so we're going to get a 1/2 minus 1/2 ln of x squared plus 3 plus c. Okay? And so if you like, you could go 1/2 times 5 ln absolute value of x. You probably should do this, right? Then factor out the half. Minus the ln of the absolute value of x squared plus 3 plus c. Yeah, you really have to.
Shouldn't it be 3/2 c?
Yeah. No, because the c was always outside the brackets.
Ooh.
Ooh. Oh no.
Ooh.
Oh no.
Ooh. Plus, he's also
I got-
specifically said multiple times that you don't need to change the constant value if
I
you're
got
adding
it
certain
double.
values
I
and
was not
multiplying
aware.
it. Fight me.
I know, no, I know he knew.
I got a double wrong.
If the degree of the denominator, so far we've worked with degree of denominator is greater than or equal to. If the degree of the denominator is less than or equal to the degree of the numerator, then what we do is we divide. Long division. So we divide x plus 2 into x minus 4. So x goes into x how many times? Once. 1 times x plus 2 is x plus 2. X minus x is 0. Negative 4 minus 2 is negative 6. So we can now write this expression as the integral of 1, the quotient, minus 6 over x plus 2. That's the remainder, right? Like you've got 6 over x plus 2. Same as if you're dividing 30 by 7, it's 4 and 2/7, right? You know, with the remainder of 2 sitting down at the bottom. But that's 2 over 7. This is negative 6 over x plus 2. Okay, which is, now this is quite doable, right? So you just got a 1, which is x. Minus, you got this, which is 6 ln of x plus 2 plus c. That's why we didn't give you a whole pile of room for that one. It didn't need much room. Okay, so that's how you do that. So, if degree of denominator is less than or equal to degree of numerator, you have to divide it out. Okay? And you're going to end up with something, some expression up here. Might be a little more complicated than this. And some remainder. And the idea is just remember the remainder is this divided by this. And if that's just a number, then this is really easy to do. Because in this one, the division's a little bit more, right? It's a little more complicated division. So we got x squared plus x minus 2 dividing into 3x to the 4th plus 3x cubed minus 5x squared plus x minus 1. And remember, when you're doing long division, if you don't have a factor, like if there was no cubed in that, 3x to the 4th, then I would write plus 0x cubed. Right? Because when I go to do we decide how many times does x squared go into 3x to the 4th? Okay, how many times does x squared go into 3x to the 4th? 3x squared times, right? So 3x squared. When we go to multiply this out, we will get an x cubed. We need a placeholder here, just in case there was. Now there is, everything's in there, right? But you need a placeholder, because things have to be written. So 3x to the 4th, what do we got? Plus 3x cubed minus 6x squared, and we subtract. And then, oh, that's nice, the x cubed is gone, and what do we get here? Just plus x squared, right? So we get a plus x squared, we're going to bring down the x and the 1. Well, the plus x and the minus 1. X squared goes into x squared how many times? Okay, so plus 1 gives us x squared plus x minus 2.
Yeah. What?
Subtract, what do we get? Yeah, you think they did this on purpose. Yeah, it's fine.
Yeah.
Yeah. What's negative 1 minus negative 2? 1. Okay, so we have a remainder of 1, right? We have a quotient of 3x squared plus 1. So this whole thing here is equal to the integral of, well, the quotient. So 3x squared plus 1 plus 1 over x squared plus x minus 2 dx. Now, the first two guys are easy to figure out, right? I mean, 3x squared, that's just x cubed. Plus 1, that's just x. The other one, we're going to use partial fractions on it. Okay? So we got to go again. Okay, this, easy x cubed. This, easy x. This, we got to decide here, right? So we want to do 1 over x squared plus x minus 2. So how does that factor? What do we got? X plus 2, x minus 1?
Yeah.
Okay, so we're just doing partial fractions again, right? Well, actually, we're just doing partial fractions. We didn't even really do that the first time we did this. And then we said, oh, now we've got a partial fraction. So a times x minus 1 plus b times x plus 2 is equal to 1. Okay, so what do? Well, we let x equal 1. If x is 1, what do we get? 3b is equal to 1, and b is 1/3. And then what do we let x equal? -2. If x is -2, this is gone. We get -3a is equal to 1, and a is -1/3. Okay. Right? So I want to do the integral of 1 over x squared plus x minus 2 dx. And that's equal to, well, let's put the b first just because it's positive, right? So b positive. So 1/3 the integral of 1 over x minus 1 dx. Then we've got the negative, so minus 1/3 the integral of 1 over x plus 2 dx. It's like squashed in there. So 1/3 is common here, right? We got a 1/3, so that's equal to 1/3. Just imagine taking it out and then just doing these guys. So ln x minus 1, not a curve, minus ln x plus 2, plus some arbitrary constant, which I will call C1. And now we can go back here and do this. Okay, because we have this integral, right? Sitting there, it's just waiting to be plugged into place. So this is equal to, okay, x cubed plus x plus 1/3 ln of x minus 1 minus 1/3 ln of x plus 2 plus c. Not C1, different C.
I'm not
And it's better if we write this with a common denominator of 3. Okay? So it's better if we go, let's put a 3 on the bottom, which means this has to become 3x cubed plus 3x plus ln minus ln all over 3
Plus C.
plus c.
It's not.
It was a 3c. It's a third of what it was. Okay, here. So this will be C2 and this will be C3.
Q. Nobody knows not.
Okay, so anyways, degree of denominator less than or equal to degree of numerator, do a division, you're going to get a quotient. That just becomes, you're just going to take the integral of that. And you're going to get a remainder, which here was, whoops, too far, which here was an easy remainder, right? Negative 6 over x plus 2, you go straight to the antiderivative. And here was a remainder requiring partial fractions.
Oh yeah.
Okay, and then writing it all out. The challenge questions, and we're not going to do the challenge question, but what I'll do is, did you get a hint? You can get a hint. Here's a hint.
It's on my paper.
Oh, you have a hint on your paper, right? It says what? Let u equal the square root of x plus 4. Okay. Then what you want to do is you want to solve that for x. And then you want to express u in terms of that, and then it's just working through. So you have to do a substitution. You're doing a u-substitution, followed by you're going to end up with a little more complicated expression there, which is then going to involve partial fractions, and you can ultimately solve it. Okay. And I have this solution up here, which you are free to look at any time. But it's a challenge thing. Give it a shot, see what happens. That's why we didn't give any room for it. Right? Because it takes like that much space.
Okay.
Okay.
The answer. Oh my god.